In this video, we're going to look at derivative as rates of change. So we know a rate of change when we're looking at a graph is talking about the slope of the graph at any particular point. And now that we've been working with that, we know that the slope of a graph is really just what we call the derivative. So these three things are kind of all the exact same thing. So we can talk about them in terms of a position function. So a position function we call s of t. Sorry, I'm sliding the whole graph. S of t is just the name for what we give position. So if we want to find my instantaneous rate of change, the velocity at any instant, the v instantaneous, that's just equal to the derivative of my position function, which I could also use the limit as x approaches a of f of x minus f of a over x minus a, which is the slope of the tangent line at that specific value x equals a. So our velocity has a direction and an amount, like it tells me the speed and the direction I'm going. If I look at the absolute value of velocity, I get speed. It only tells me my magnitude, not the direction. For instance, if I have a negative velocity, it means I'm going down. If I have a positive velocity, it means I'm moving up. And acceleration is the rate of change of velocity with respect to time. So acceleration is the derivative of velocity, or we could say acceleration is the second derivative of the position function. So we're given the position function s of t is equal to t to the third minus 21t squared plus 60t, and we're only looking at the interval from 0 to 6. We want to know when and at what time the velocity is actually equal to 0. So we have to do two things first. First, we have to figure out what is our velocity. So to find my velocity, v of t, I have to find the derivative, s prime of t. Okay, so I'm just taking a derivative. I'm using my basic power rule. So 3 times 2 is 6, so this is 6t squared. 2 times 21 is 42t plus 60. So that's my velocity. I want to know when that equals 0, so I'm just going to set it equal to 0. So 0 equals 6t squared minus 42t plus 60. And in order to solve this, I'm going to factor out my GCF, which is 6. So I'm left with t squared minus 7t plus 10. I can keep factoring, so I have 6 times t minus 5, t minus 2, and when I solve, I find that the time is equal to 5, or the time is equal to 2. Now both of these are in my interval 0 to 6, so that means that there are 2 spots at which that position function has a velocity of 0. So t equals 5, and t equals 2. Okay, let's try another one. It says, for Halloween this year, you are going to have a pumpkin dropping party. Your party takes place on the roof of a building that is 80 meters high. The equation that models the height of the pumpkin as a function of time is given by s of t equals 80 minus 5t squared. How high is the pumpkin at the instant it is dropped? Well, if I'm just about to drop it, that means I'm just starting. That means when my time is equal to 0. And I want to know how high it is, so that's position, so that's s of 0. Is equal to 80 minus 5 times 0 squared. So this is equal to 80, and my units are meters. So it's 80 meters high when I start. And that's what that part of the equation is telling me. Then it asks, how long does it take for the pumpkin to hit the ground? Well, if I'm starting, and here's my roof, and I'm standing up here, and I drop my pumpkin down to the ground, its height here, if this height up here, starting height is 80 meters, this height down at the ground has to have a height of 0 meters. So I want to know what is s of 0. So we want to know when the height is 0. So s of t has to equal 0. So to solve for that time, I have 0 equals 80 minus 5t squared. I added 5t squared to both sides, so 5t squared equals 80. Divided both sides by 5, so I have t squared equals 16. I take the square root of both sides, I get t equals plus or minus 4. This is in seconds. I can't have negative seconds, so I know that my answer is positive 4 seconds. I can't go backwards in time, so I can't have negative time. All right, so we know how long it takes to get there. So then this last question says, how fast, so fast is telling me it's a velocity question, is the pumpkin going when it smashes into the ground? Well, if I'm talking about velocity, I better figure out what my velocity equation is. So remember, v of t is just the derivative, s prime of t. So the derivative of 80 minus 5t squared, that would be 0 minus 10t. So this is just equal to negative 10t. So we want to know the velocity when time is 4, v of 4. So that's negative 10 times 4, which is negative 40 meters per second. So it's going at a decent pace as soon as that falls. Now, besides dealing with velocity and position and acceleration, we can also use calculus and derivatives to deal with average and marginal cost in a business. So C of x would be a cost function, which tells us what the cost is to produce the first x items. Cx with the bar over it is what we call the average cost, and it's just the cost, C of x, divided by the number of items we sold, so it's just finding an average. And then the new one, the calculus part, is C prime of x. The derivative of that cost function is what we call the marginal cost. And this is just the approximate cost to produce exactly one more item, the x plus 1 items.